In Spark, you must have heard the terms driver, executor, cluster manager, stage, task, etc. In this video, you'll understand each of these terms and Spark application execution in an easy way using a real-world simple example of a restaurant. So let's get started. We have a very famous pizza restaurant which prepares the most delicious pizzas in the whole city. On one fine day, two guests dine in the restaurant. The server takes their order. The two guests orders two pizzas. The server writes the order and reaches to the kitchen head chef and gives the order to her. The head chef is the main person who is responsible for getting these pizzas prepared. Looking at the order, the head chef plans all the tasks which would be needed to prepare the pizza, including the preparation of the dough, flattening of dough, applying the sauce, putting the toppings, baking the pizza in oven, and finally plating the hot pizza onto the plate. The head chef gets the clarity about what all tasks need to be done. Except the preparation of dough from flour, the tasks such as flattening, topping, baking as well as plating are required to be performed individually for each pizza. So there will be two separate tasks for two separate pizzas. Now the head chef calculates the number of line chefs she would need. She needs 5 line chefs. Besides the line chefs, head chef needs dough maker to make the dough, a kitchen station to roll and flatten the dough, kitchen station with the toppings and sauce, ovens to bake the pizzas, and then plates to finally plate the pizzas. Having the clarity of what all she needs, she reaches out to the kitchen's operations manager. And it is operations manager's responsibility that he provides all the required line chefs and the utilities such as the dough maker, oven plates to the kitchen head chef. Once these are available, the operations manager gives a thumbs up to the head chef. Now it is the head chef who knows which particular line chef is best for which task. She assigns the respective tasks to the line chefs. Each line chef works on their assigned task, and the preparation of this pizza happens in stages. The plated delicious pizzas are delivered by the server to the two guests and they enjoy the pizza. Now that you understand this pizza preparation process, understanding Spark application execution would be easy for you. Let's see how simple it is now. The kitchen head chef is actually the Spark driver, and the order it received is the Spark application code. The driver looks at the application code and understands all the operations which are required to be performed to fulfill client's needs. And these involve the transformations and actions. And the driver forms a lineage graph which is called a DAG. When the action is received, the driver materializes the DAG and breaks it into tasks which it needs to get performed, which in this case are the individual tasks to prepare the pizza. The line chefs are the executors who actually perform the task. And all of these resources, including the dough maker, the kitchen stations, oven, plates, are the containers and resources which are required by the executor to perform the task. The operations manager is the cluster manager who provides the executors and all the resources required by driver. The tasks which can run on the same data partition are executed in stages. As mentioned, cluster manager is responsible for provisioning the executors and all the containers and resources required for execution of tasks. Executors run individual tasks and the tasks running on the same data partitions are clubbed into stages. So when we submit a Spark application using Spark Submit, this is the point when the driver gets activated. The driver instantiates a Spark session object. Spark session object is the entry point for every Spark application for executing the different operations from Spark's API. Spark session also encapsulates all the Spark configuration and acts as an interface between the user and the Spark engine. The next argument, which is the master, controls what is the cluster manager being used for the Spark application. Depending on the value of this argument, the cluster manager can be Hadoop Yarn, Apache Mesos, Kubernetes, or even a standalone cluster manager. As the driver reaches to the cluster manager provisions executors on the worker nodes. When the executors are provisioned, they register themselves back with the driver. This is something like a security camera within the kitchen, through which the head chef keeps a track of the status of line chef's work, and also if any of them, let's say, get sick, he can replace them with other chef, and the preparation of pizza is not getting affected. Now, the data which needs to be processed resides in a separate file system. As Spark does not come with a file system, the storage can be S3, Hadoop's HDFS, Azure Blob Storage, and various other storage platforms. Based on the block size of these external file systems and consulting the file format of the data files, Spark generates the logical partitioning of this data. Usually a Spark's partition directly map to the partitions of these external storage systems, but you can always repartition your data using different Spark functions such as repartition or coalesce. A task executes on a data partition, and each task executes in one core. The executors also have their cache, which is used for caching the data which needs to be reused, and driver keeps a track of this cache data so that it can efficiently utilize this cache data later. Num executors is the argument which controls the number of executors. Executor memory is the argument which controls the size of executor memory or cache. Executor cores argument controls the number of cores available on the executors. You can always control this configuration through the arguments. But if you do not specify these arguments, Spark uses dynamic allocation through which it dynamically allocates the resources, including the memory, the cores, the number of executors, which would be most suitable and optimal for your Spark application. Hi, I hope you found this video helpful, because your learning and growth is the goal of this video. Thank you for watching.